guys, welcome back to my YouTube channel. So today we are going to solve day 25 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 2416, sum of prefix scores of strings. Okay, so this is a hard level problem, but I will say that if you guys have solved yesterday's problem, then this question is going to be a little bit easy for you. Okay, so let's read the problem statement first. You are given an array words of size n consisting of non-empty strings. Okay, so we have given an array of strings, okay, which contains non-empty strings, right? All these strings are non-empty. We define the score of a string word as the number of strings words of I such that word is a prefix of words of I. Okay, so let's understand this line with this example first. Okay, so here let's say this is my words string array, right? Then the score of AB is 2, since AB is a prefix of both AB and ABC, right? So here I want to find the score of this AB. So see here, this AB and this AB, right? So in both these strings, this AB is prefix, right? And in other strings, you want to see this AB as a prefix, right? So that is why the score of AB is 2. We have to return an array answer of size n, right? Where answer of I is the sum of scores of every non-empty prefix of words of I. Okay, note that a string is considered as a prefix of itself. Okay, so let's understand this with example number 1 here. Okay, so this is input given to us and this is output. So let's see how this output is coming. 5 4 3 2, right? So here first see this word ABC. Okay, so here I can have one prefix as A, I can have one prefix as AB, I can have one prefix as ABC. Okay, so only these three are the possibilities, right? Okay, for this particular string, these three are the possibilities. Okay, these three can be the prefixes. So let's search the prefixes A. Okay, let's search this. Okay, in all my strings. So here this string has this prefix A. Okay, this string also has this prefix A. Okay, so let's write the count of this A as 2. Okay, because this A is the prefix 2 times. Okay, in this word string array, here and here. Okay, now this ABC has this prefix as, this could be one prefix, right? AB. So let's search for this AB. So this AB is prefix here, this AB is prefix here as well, and yeah, just 2 times. So here write 2. Okay, and this string can have this as prefix ABC. So let's search ABC, right? Let's search this ABC. So 1 time here, and there's nothing else, right? So here just 1 time. So what is the total count here? I'm getting 2 plus 2 plus 1, 5. So that is why you are seeing 5 as output. Okay, so here let's read this first line. The answer for each string is the following. ABC has 3 prefixes, right? A, AB, and ABC. There are 2 strings with the prefix A, 2 strings with the prefix AB, and 1 string with the prefix ABC. The total is answer at 0 index is 2 plus 2 plus 1 is 5. Okay, clear? Now let's see this string. Okay, so from this string there are possibilities like A as one prefix and AB as prefix. Okay, so here don't say here that B is a prefix. No, our prefix should always start from 0 index, right? So that is why I'm writing A, AB, and ABC. Here I'm writing A and AB. Okay, I can't write B here. B is not a prefix, right? So our prefix is always going to be start from the first 0th index, right? So there are 2 possibilities, A and AB. Okay, so let's search A. So A here 1 time, here 1 time, here 2 times. Okay, so this A 2 times. AB, search for AB. 1 time here, 1 time here, 2 times, right? So AB2. So that is why I'm getting 2 plus 2 as 4 here. Okay, now check this string BC. So 2 possibilities, right? B and BC. Okay, so let's check these prefixes. So this B, yeah, 1 time here and 1 time here. Okay, here and here 2 times. Okay, let's search this BC. BC is appearing just 1 time here. So here count is 1. So B is 2 and BC is 1. 2 plus 1, 3. So that is why I'm writing 3 here. Now for B, search for B. So B is appearing 1 time here and 1 time here, so 2. So that is why I'm writing 2 here, right? Prefix I have to search, and prefix always going to start from 0th index. Okay, that's why it is prefix. Okay, so I hope that you guys are clear how we are getting this output. Okay, so you can go through these lines. Okay, the explanation given in the problem examples, right? You can go over this. Okay, so I hope that you guys are clear how we are getting this output. Okay, so now let's see how we have to solve this problem. Okay, so we have to simply construct a trie data structure in this problem. Okay, so here these are the words, right? A, B, C. So let's say first word is ABC. So what I'm going to do, so in my trie data structure, there is going to be first one root. Okay, then after that I will see, okay, let's say first I'm at this particular index. Okay, I is at this particular index. Then I will see if this root has this children A. No, this root doesn't have this children A. So I'm just going to add this children A here, and I am going to calculate the score side by side. So let's say this is first time it is coming right here, so I am writing 1 here. Okay, then my I is going to move to the next position. Okay, so initially, now let's say this becomes my current node. Okay, current node CN. Okay, so initially this was my current node. I check if this current node has any children named A. No, it doesn't have any children named A, so I have added A, and then after that my A will become my current node. Okay, so that is why this is CN. Okay, current node. Okay, then there is no children named B for this current node A, right? So I will add B here, and I will just update the score of this one as 1. Okay, because this is actually for first time. Then my eyes move to the next index. Okay, then this will become my current node. Okay, this will become my current node, new current node, right? Then for this current node I will see that if we have children named C. Okay, so C is not there, so I'm just going to add this C. Okay, then I will just update the count as 1 for this one. Okay, so now I have constructed my trie for this ABC. Okay, now next word is AB. Okay, A and B. Again I'm going to start from my root. So I will see A is there. So right now my I index is at this position. A is there. Yes, A is already there. So just increment the count of this A to 1 by 1. So now it will become 2, right? And then I will search for B. So A will become my current node, and B is already there. So just increase the count of this one. So this count of B will become 2 here. Okay, so I hope that you guys are clear to you now what I'm doing. Okay, so next word is BC. Okay, so BC. So now my I index is that here. Okay, again I'm starting from root. I'm going to check here if my root has this children name B. No, this root has children A only. So here I'm just going to add the new children B. Okay, and here I'm just going to update its count as 1. Okay, because this is appearing for first time. This B is here, but this B is the children of A, not root, and this B is the children of root, right? So that is why here I'm writing count as 1, not 3. Okay, then my I is going to move forward. So now B is going to my current node, and for this B I will check if C is the children or no. No, C is not there, so I'm going to add C. So here count of C will become 1. Okay, this is done. Now let's construct trie for this B. Okay, B. So now my I is at this particular index. So for this root I see B is already there, so I will just increment the count of this with 1. So now the new count of this one will become 2, right? 2 is the new count for this B. Okay, so I get the score at all the children's, right? So these are the scores. Okay, so now what I need to do, these are the scores. For this A, 2 is the score. For this B, 2 is the score. C, 1 is the score. For this B, 2 is the score. And for this C, 1 is the score. Okay, so now what I need to do, I have to calculate the score, right? A, B, C, A, B, B, C, and B. Okay, so I have these options: A, B, C, then I have A, B, then B, I have B, C, and then I have B. Okay, so I have to calculate the scores. Okay, so let's say I'm going to write the scores here. Okay, so now how I'm going to calculate the score? So first I am at this particular word. Okay, so let's pick this word ABC. I have to write the score here for this ABC. Okay, so here what I'm going to do here, I'm going to move. Okay, initially I'm at this root, I'm moving to A, and I will check the score at A. So at A score is 2. Okay, then after that A, I'm moving to this B, and at B the score is 2. Okay, so 2 plus 2. Okay, right? And then after that B, I am moving to C. Okay, so at C count is 1, so here I am writing 2 plus 2 plus 1. So what is the output? I am writing 5. So let's write 5 here, and this is correct now. This 5 is correct. I have already explained here. 2A, AB is 2, and ABC 1 time. Okay, so this is correct. Okay, here I am writing 5. Okay, this is done. Now AB, again I am starting from root. A count is 2 and B count is 2. Okay, so here 2 plus 2 is 4. Okay, I am writing 4 here. Then BC, so here I'm coming. Okay, B 2 and C is 1. 2 plus 1 is 3. Okay, I'm writing 3 here. Then B. Okay, so here I'm going to B, and the count is 2. Okay, so 5 4 3 2, is it the my correct output? Yes, 5 4 3 2. Okay, so this is how we need to solve this problem. 5 4 3 2 is coming, right? So here I have added the debug statement. So what we are doing, we are first inserting this word ABC into trie. Okay, then we are creating a new node for character, because initially I'm starting from root now, so we have to create a new node for character A, then word ABC is going on, index 0, character A, current score at this node is 1. Okay, then create a new node for character B, right, and word ABC index 1, character B, current score at this node is 1. Then create a new node for character C, we need to do current score at this node is 1. So this is done. So for this is for ABC. Then after that we have to insert word AB. So word AB index 0, character A, current score at this node will be incremented to 2. Okay, so just go over this statement A, and then I am inserting B. So B is already there, so its count will become 2. Then we have to insert this word BC, right? So we have to create a new node for character B. Okay, from here root itself we need to check now again and again. So word BC index 0, character B, current node at this score will become 1. Then we have to create a new node for character C, and then this count will become 1. Then we have to insert word into try B. Okay, then this count will become 2. Then we have to calculate the prefix score for the word ABC first. So calculating score for word ABC, so at A running score is 2, then at character B running score will become 4 by 2 plus 2. Okay, and calculating score for the word ABC, character C running score is 2 plus 2 plus 1, right? So I have already explained here. So by 5 is coming. Okay, so this is the prefix score, how it is coming. Okay, so this is nothing but dry run. Okay, so now I want you guys to pause the video. If you already know about this trie data structure, try to code it. Now I'm moving to the coding part. Okay, so what we need to do, let's see. So it's going to be very easy. Okay, very easy problem. If you guys have already solved yesterday's problem using trie data structure, then you are already aware of this trie, right? So what we need to do here, first let's calculate the side of this words array. Okay, so words dot length, and then here do one thing, we have to score, we have to store the score as well, right? And we are using trie, so here write private class trie, and here trie children, and new here trie, and here we need to give size as 26 because we are dealing with only lowercase English letters, right? A to Z. So 0 to 25 index, so I have to write 26 here, right? And we are also dealing with the scores at each level, so here I'm just going to create one int score as 0. Okay, that's it. So here let's come inside this now. Int n is equal to words dot length, and here after that let's initialize this root. Trie root is equal to new trie. Okay, and then after that just iterate over all the words in my strings words array. Int I is equal to 0, I is less than n, I plus plus, and here inside this take the current word. Okay, so let's pick this word first. So here I'm just going to write string cur is equal to words at I index. Okay, I pick this particular word. Then after that I have to make a trie for this particular word. So make trie, I'm going to call this method make trie, and in this I'm just going to pass my current word, and I'm going to pass the root. Okay, every time I have to pass the root. Okay, so this is done here. Okay, so here I need to write few lines. Okay, but first let's see how this make trie is working. Okay, so let's write the code for this one. So here private void make trie. Okay, so here in this I am passing the current string, so you can just copy this, paste it here, and also I am passing the root, so just copy this and pass the root. Okay, so here just write trie root, and after that inside this let's first calculate the length of this particular word. So here I'm just going to write int n is equal to, since this is string now, so I have to write like this current dot length, right? And then after that let's iterate over all the characters of this one. Int I is equal to 0, I is less than n, I plus plus, and here inside this let's first select the index of the first character. Okay, char index, how I'm going to do that, char dot char at this particular index I, and I'm just going to subtract a from it. Okay, so if my current character is a, I will get my char index as 0. Okay, if my current character is b, I will get my char index as 1. Okay, so a minus a is 0 now. So this is how it's working, right? I hope that you guys are already aware of this line. Then here I'm going to check if my this root, okay, this root, okay, so let's name it as current node. Okay, current node, because it is going to be updated. Initially I'm going to pass root, but then after that I have to make it current node every time. Okay, so here what I'm going to do, I'm going to check if my cur node dot children at this particular char index. Okay, at this particular char index. Okay, so we have this children type array now. So if current node dot children at char index is equal to null, if it is equal to null, then simply means if we don't have that children. Okay, so let's create that. So what I'm going to do, current node dot children at char index is equal to, so I'm just going to create a new try for this one. Okay, new try, that's it. And then after that I'm just going to point my I'm going to update my current node now. Every time current node is equal to current node dot children at this particular char index. Okay, so after inserting a here, then it will become my current node, right? So this is what I'm doing here. This is done. And then for this particular current node, just increment the score now. So current node dot score plus plus. So for this particular I have to update the score as well. Okay, so that's it. That's what we need to write in this make try. Okay, so that's it. Okay, this is done. This is done here. Okay, so once we have constructed this make try, okay, then what we need to do, then after that here I'm going to write remaining code now. Here write int result. Okay, now we have to calculate the result, and the result is going to be of same size as my words string array length. Okay, new int, and here I can write n. Okay, new int n. Okay, let me just format the code. Okay, now it looks good, right? So here a new int n, and now after that what we need to do, just iterate. We have to just iterate over all the values one by one. Int I is equal to 0, I is less than n, and I plus plus. Okay, this is how I need to fill the values, right? And here how I'm going to update my result of I. So in result of I, I'm just going to call one method get prefix score. And how I'm going to get the prefix score, so for that particular words, okay, for that particular word I need to get the prefix score, right? And here I'm just going to pass root because I have to start searching from root, right? So in this way I'm just going to store the result, and here I'm going to return result. Okay, so now let's write this get a prefix score. Okay, so here this is also going to be very simple. So private int get prefix score, and here you have to just pass the string word. Okay, and you can pass try root because we need to start searching from root every time, right? And here what I need to do after that, so here just initially score is 0. Okay, now at each level I have to calculate the score. Int score is equal to 0, then I'm just going to make my current node as root. Okay, this is my root, and then after that I have to just iterate over int I is equal to 0, I is less than for that particular word. Okay, let's calculate the length of this word. So I is less than word dot length, and here just write I plus plus, and now after that just pick that particular index. Okay, int char index is equal to word dot char at that particular I minus a. Okay, this is how I'm going to get the indexing based on numbers, right? And this is done. And after that current node, I will update my current node as this current node dot children. Copy this, one second, copy this. Current node is equal to current node dot children and char index, and then after that I have to just update my score as score plus current node dot score. Okay, so this is what I was doing right last time. Here 2 plus 2 plus 1 score. Okay, initially it is 0, then after that for each current node I was adding the score one by one, and this is how I'm filling the values, right? So this is done. Okay, and yeah, that's it. Okay, so we are first making a try, and from here I will make the try, and then after that we are just calculate the prefix score. Okay, so here for result of 0 I will call this for the current word, and for that current word I will just calculate the total score. Okay, and here I will write a return score. Okay, I have to write a return score as well. Return score. Okay, then I'm returning score. Okay, so 5 for first one, so I will just add 5 in this result of 0. Then after that I will call for the next word, then again I will calculate score. I will get that. Okay, so here if you see, here I'm iterating over all the words in my strings array one by one. So time complexity for this one is going to be of n. Okay, then I'm calling this make try, right? In this make try also I am running this loop for the current word length. Okay, so let's say the current word length max length, let's say of l. So of n, then inside this for this of l, so of n into l. Okay, for this part of n into L. Then same way for this one of n, it is running of n times. Then here get prefix score. Here it is also running for the word's total length. Okay, so of L. So of n into L plus of n into L, or you can simply say of n into L. N is nothing but my words string array's length, and L is nothing but the particular word length. Okay, so of n into L is going to be my time complexity. So now let's run it. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted. Okay, and the time complexity is nothing but of n into m, or n into L, you can say anything. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.